secret to improved performance at Catawba Nuclear Station in South Carolina and at the Callaway Nuclear Plant in Missouri is buried underground. And at both plants, the secret is plastic. High-density polyethylene, to be precise.
The high-density polyethylene is one of the most durable pieces of material you're going to find.
We knew from looking at other industries, like the petroleum industry and elsewhere, that there was a lot of use made of plastic pipe and other applications.
The teams at Catawba and Callaway have received a top industry award for replacing carbon steel pipes with the high-density polyethylene pipes.
Typically, engineers rely on performance they've had with current equipment. So if something breaks, I'm going to replace it with something in kind. And in this particular case, they recognized that they could use polyethylene pipe and install it more efficiently, and it would be as effective, if not better, than carbon steel piping for these applications.
Carbon steel is a pretty tough material in its own right, but over a number of years, when exposed to water and chemicals, it will slowly begin to deteriorate. The outside of the pipes weaken, and mineral deposits build up on the inside of the pipes, interfering with the flow through the pipes. None of that happens to plastic piping, and it's also much faster and easier to install.
We can install up to 400 feet of plastic pipe in a normal day, just working a normal shift. And that's taking like 20-foot sections of pipe and fusing roughly 20 joints. If you looked at a comparable doing metal welding, you may be able to weld 2 or 3 metal joints in a day.
There are industry regulations in place for inspecting and replacing the steel carbon pipes, but at Catawba and Callaway, operators took an innovative step and proposed an even better alternative, which is becoming a new industry standard both for existing plants and in plans for new plant construction. Innovations like these are a key reason that nuclear power plants operate with far greater reliability than they did just 15 years ago. Today's nuclear plants have a 90% capacity factor, meaning they operate virtually around the clock all year long.
With things like plastic pipe and other innovative applications, I think we bring to bear the kind of tools and capabilities that allow nuclear to stay viable, to be cost competitive, to be one of the key solutions to the whole carbon issue that we're wrestling with today in terms of how we minimize the footprint of carbon.
This high-density polyethylene material will be around after I'm gone and will most likely outlive the plant.